Good evening, Bearcats. This is 3.3, Properties of Logarithms. We're going to start tonight and discuss change of base. With the new calculators that we're having, our Inspires, you actually can put in the base in your calculator, but most calculators only have two types of log keys, one for a common logarithm, which is base 10, and one for a natural logarithm, which of course you know as base e. Although common logs and natural logs are the most frequently used, you may occasionally need to evaluate logarithms for other bases. To do this, you can use the following change of base formula. The change of base formula is important whether your calculator can calculate that or not. So let's take a look at the change of base formula. You can see the definition here, and we have several bases. We have base B. Base B simply represents any base that you could have. So B represents, you know, base 2, base 3, base 4, whatever you would like that to be. So you would change your log base AX into a common base B. So log base BX over log base BA. Notice that the base of the original log is in the bottom. That kind of helps remember it. Bases are in the bottom. Base 10, same thing, log base or log X over log A, both having base 10 as their base. And then of course base E. So you can switch from a regular logarithm or common logarithm to a natural logarithm by using ln, which is base E. So ln x over ln A actually could be written as log base EX over log base EA, although we wouldn't really use E, we would use the ln key in our calculator. A couple things that we're going to learn in this unit is using the change of base formula, which we just discussed. We're also going to use properties of logarithms to evaluate and rewrite our logarithmic expressions. We're going to use properties of logarithms to expand and condense, and we're going to do all of that this evening in this video. And then we're going to use logarithms to model real-life problems, and we'll do that tomorrow evening. All right, let's move on. Let's take a couple examples on our change of base. Let's start with this example. We'll just call this example 1. If I were to give you log base 4, 25, you could rewrite that in several ways. We could write it as log base 10, 25 over log base 10, 4. We could rewrite that as ln 25 over ln 4. We could rewrite that as log base 2, 25 over log base 2, 4. Now we would have the same problem in a regular calculator with log base 2. But those are just several things, and they're all equivalent, and I wanted you just to understand that. If we need more explanation and that is not clear, then ask me in class. Let's move on to the next topic. All right, we're going to talk about the properties of logarithms. We know from the preceding section that logarithmic functions with base A are the inverse of exponential functions with base A. We understood that logarithms and exponentials were inverses of one another if they carried the same base. So it makes sense that their properties of exponents should have corresponding properties involving logarithms. So they're going to seem kind of similar. We have similar properties. For instance, the exponential property a to the 0 power is 1 has a corresponding logarithm property that log base A1 is equal to 0. Notice how the 0 and the 1 have switched places because they are inverses. All right, let's just take a look at these properties. These properties are something I would pause the video and definitely have in my notes. Matter of fact, I think we're going to start a card this time for you to keep your notes on for key information. This would be one of the things tomorrow when I give you a card, and if I forget, ask me in class. I want you to write this on your card. Go ahead and have it in your notes and then transfer it to your card. Just in that transference over, you're going to learn the properties even better. The definition is here, and then the product property. Of course, if we have base A and we're multiplying U and V, then we could expand that. These are all expanded. We can make it log base AU plus log base AV. We did do this last year in Algebra 2, so it's the second time you're seeing it. Again, the natural logarithm version would be ln U plus ln V. For our quotient property, of course, the inverse of division then would be subtraction, and so we would have log base AU minus log base AV. And then our power property. This is a little unusual. We're going to take that power, that power over here, and we're going to move it to the front. So n times log base AU. And ln would be u to the n power is the same as n times ln u. You do get, I want you to notice something over here. This is just a study tip that I've written down or copied over from our book, that there's no general property when we are actually adding. These are all from multiplication and division and a power. So product, quotient, and power, not adding and subtracting. So be really careful. So in other words, the log base AU plus V is not equal to log base AU plus log base AV. Those are not equal, kind of an important concept. So make sure and take a look at that study tip. All right, we're going to talk about rewriting our logarithm expressions. Using our properties that we just discussed, and hopefully you have written in your notes. If you didn't, make sure you go back and pause and write those down. We can use those in rewriting our logarithm expressions in forms that simplify our operations of algebra. And that's true because the properties convert complicated products and quotients and exponentials into simpler sums, differences, and products. So a couple of things. Let's go ahead and do a couple of examples here on expanding our expressions, So the first one we're going to use is we're going to say log base 4. This is just an example. We'll have log base 4, and we'll have 5x cubed y. All right. All of that's multiplication. The 5 times the x cubed times the y is all multiplication. So as in our product property we saw, we're going to separate that, give each one the same base, give each component of this the same base 4, and we're going to expand it by putting addition in between each term with its own base. So the first step we would do is that we would rewrite this as log base 4 5 plus log base 4 x cubed plus log base 4y. And then we also notice in the middle term that we have a power property. So we would want to take that 3 and we want to move it to the front. So let's do that. And so we would have log base 4 5 plus 3 times log base 4x plus log base 4y. And that would be how we would expand. Now, let's go ahead and take one that's a little bit different with a natural log. Let's do another example over here. I'm going to go over here to the side, and we'll do a second example. This example is natural log ln, and we have the square root, it's a little bit more complicated, of 3x minus 5 divided by 7. Okay, the first thing we're going to do is we're going to rewrite our square root as a power. And that's not something that you might think to do if you had not seen it, so please be paying close attention. So we would have ln, and we would write it as parentheses 3x minus 5 all to the 1/2 power. We're going to write that square root as a half power all over 7. And then we see a couple of things here. The big picture we see is we have division. And if we have division, we're going to give each our base log and ln, which is a natural base e log, and we're going to separate the terms by subtraction. So the first step, or the next step we're going to take, is we're going to go ln 3x minus 5 to the 1/2 power, and we're going to subtract ln 7. All right, now we're going to take that half power, and that's our power property, and we're going to move it to the front. So we would have 1/2 ln 3x minus 5 minus ln 7. And that's how we would expand. A little bit later on, we're going to use that expansion to solve things. Notice again, I have a little note here in red about a common error that's made when you expand logarithms. I want you to note when we rewrite log axn as n log ax, instead we take this, and instead of we don't want to write, sorry, the error is to move that exponent to the front before we separate. We need to make sure we've separated. So we need to make sure we've given log base, in this case 10a, plus log base 10x to the n power. Then you move the n in front. So make sure you separate that multiplication part before you move the use that power property. All right, let's go on and talk about condensing our logarithms. Be our last topic for the evening. We're going to talk about condensing logarithms, and that's just the reverse of what we just did, the reverse properties, and we're just going to use them to condense. So if we have addition, we'll put it back with multiplication. If we have subtraction, we put it back with division, and if we have something being multiplied in the front, we'd move it back as a power. So we're going to condense our logarithms. And there will be special cases where we'll want to do this. Let's take a couple of examples here. So we're just going to take an example. And the first example we're going to take is 1/2 log x plus 3 times log x plus 1. All right, so let's go ahead and try to condense this. The first thing I see is I'm going to move the 1/2 back as an exponent, and I'm going to move the 3 back as an exponent. So let's do that first. So we would have log x to the 1/2 power plus log, and of course those are base 10. We have x plus 1 to the 3rd power. To the 3rd power, because so that's the first thing that we would do. The next thing that we're going to do is we're going to make our half power actually a square root. Whenever we have a fractional power, we're going to change it back to a root. So if it was 1/3, it'd be the 3rd root, etc. So we're going to change this back, and I'm going to have log square root of x plus log x plus 1 cubed. All right, and now we want to put them together. They both have log base 10, and to condense them, they're going to share log base 10. And because that is addition, we're going to put it back together with multiplication. So we would have the square root of x times x plus 1 cubed. X plus 1 cubed. And all that would be together. We could put a bracket around it if we wanted to, just to make sure we separated it from the base 10 of the log. All right, let's do one more example, and I think that should get you started for tomorrow. And when you come in tomorrow, your assignment will be up on the board, and I want you to work through those problems in class, helping each other to make sure you're clear on what you need to do. And then I'll be around to help you as well. All right, let's take a look at the next one, and we're going to do 2ln x plus 2, and we're going to subtract ln x. Okay, so notice here we have subtraction, so at some point we should end up with some division when we condense, but we got a little step we want to take first. We want to move this 2, and we put it back as a power. So we have ln x plus 2 squared minus ln x. Now we've condensed that part. We notice that they both share natural base log, so we're going to go ln, and because of the subtraction sign, that will become our division sign, or that's where our fraction will come in. We will have x plus 2 squared divided by x, and that would be our final answer on this one. All right. Again, I think you get this. Again, I've got a little note up here that I think you want to pay attention to. A common error made in condensing logarithms is to rewrite the log x minus log y as log x over log y instead of log in the front and then x over y. So the log in condensed form, there's only one logarithm in your problem when you condense them. All right, hope you had a great weekend. I will see you tomorrow, and good night, Bearcats. Go Bearcats this week for playoffs.